Finding the ground state energy of deuteron by using variational method. A deuteron consists of two particles, proton and neutron. And these particles are attracted together by a short range force called Yukawa force, and the potential of this force is called Yukawa potential, and it is denoted by V of R. And the equation becomes V of R is equal to minus V0 e raised to minus R by beta divided by R by beta. This is the equation number 1. And here V0 and beta are constants, and R is the separation between proton and neutron. The ground state energy is the binding energy of these particles. These particles are attracted by an attractive force, that why they are held together by a single particle. Then the Hamiltonian of the system in the ground state, H is equal to minus h cut square by 2m del square plus V of R. And here the mass of the system is 2 particles. Then the reduced mass mu is equal to m by 2. Then the Hamiltonian become H is equal to minus h cut square by 2 mu del square plus V of R. This is equation number 2. The ground state energy can be estimated using trial wave function phi. The equation of phi is equal to e raised to minus alpha r by beta. This is equation number 3. In spherical polar coordinates, del square is equal to 1 by r square into dou by dou r of r square dou by dou r plus 1 by r square sin theta dou by dou theta of sin theta dou by dou theta plus 1 by r square sin square theta dou square by dou phi square. And here the equation 3 depends only on the value r, that is the del square depends only on the radial part alone. So neglect all other terms. Then the spherical polar coordinate del square is equal to 1 by r square dou by dou r of r square into dou by dou r. That is equal to 1 by r square. Then here apply the product rule. Then r square into dou square by dou r square plus dou by dou r into 2r. That is equal to dou square by dou r square plus 2 by r into dou by dou r. In the form of full derivative, we can write del square is equal to d square by dr square plus 2 by r into d by dr. Then the expectation value of H is equal to bra phi H ket phi divided by bra phi ket phi. Then apply the value of H. Then the expectation value of H become bra phi minus h cut square by 2 mu del square plus V of R ket phi divided by bra phi ket phi, which is equal to minus h cut square by 2 mu bra phi d square by dr square plus 2 by r d by dr ket phi plus bra phi V of R ket phi whole divided by bra phi ket phi, which is equal to minus h cut square by 2 mu bra phi d square by dr square ket phi minus h cut square by 2 mu bra phi 2 by r d by dr ket phi plus bra phi v of r ket phi whole divided by bra phi ket phi. This is equation number 5. Then we calculate the each integral in equation 5. We know that the expectation value of a operator A is equal to integral psi star A psi d tau. And here psi is the wave function and A is the observable. Then d tau is the volume element. So d tau is equal to r square sin theta d theta d phi dr. Here phi varies from 0 to 2 pi. Then integral 0 to 2 pi d phi is equal to 2 pi. Then theta varies from 0 to pi. So integral 0 to pi sin theta d theta is equal to minus of cos theta, and the integral the limit varies from 0 to pi, which is 2. So the angular part, that is the sin theta d theta d phi is equal to 2 pi into 2, which is equal to 4 pi. Hence the angular part contributes a factor of 4 pi in all the integrations. Then first we evaluate the denominator bra phi ket phi, which is equal to integral phi star phi d tau. That is integral 0 to infinity. Then the value of phi becomes e raised to minus alpha by beta into r into e raised to minus alpha by beta into r. Then d tau becomes r square sin theta d theta d phi dr, which is equal to integral 0 to infinity e raised to minus 2 alpha r by beta 4 pi, the angular part, 4 pi r square dr. Then 4 pi into integral 0 to infinity e raised to minus 2 alpha r by beta r square dr. And this integral is in the form of standard integral. That is integral 0 to infinity x raised to n e raised to minus ax dx is equal to n factorial divided by a raised to n plus 1. Here x is equal to r and n is equal to 2 and a is equal to 2 alpha by beta. So bra phi ket phi is equal to 4 pi into 2 factorial divided by 2 alpha by beta the whole raised to 2 plus 1. It is equal to 4 pi into 2 factorial 1 into 2 divided by 8 alpha cube divided by beta cube. That is equal to 4 pi 2 into beta cube divided by 8 alpha cube. That is bra phi ket phi is equal to pi beta cube divided by alpha cube. This is equation number A. Similarly, the next term is bra phi d square by dr square ket phi is equal to the angular part 4 pi then alpha square by beta square. Here we can differentiate alpha with respect to r square, then we get alpha square by beta square. It is a constant. Then integral 0 to infinity r square e raised to minus 2 alpha r divided by beta into dr, which is equal to 4 pi into alpha square divided by beta square into, this is also in the form of standard integral, then 2 by 8 alpha cube divided by beta cube, which is equal to 4 pi alpha square into beta square into 2 beta cube divided by 8 alpha cube, which is equal to pi beta divided by alpha. This is equation number B. Then the next term is brav phi q by r d by dr of ket phi is equal to negative sign into 4 pi into multiply with that 2 into alpha by beta, and here we differentiate phi with respect to r, then we get the constant alpha by beta into integral 0 to infinity r e raised to minus 2 alpha r by beta dr, that is equal to minus 8 pi alpha by beta, here also in the form of standard integral, and here the n is equal to 1, that is 1 factorial divided by 2 alpha by beta the whole raised to 1 plus 1, it is equal to minus 8 pi alpha by beta 1 divided by 4 alpha square divided by beta square, which is equal to minus 8 pi into alpha by beta into beta square divided by 4 alpha square, which is equal to minus 2 pi beta by alpha. This is equation number C. The last term is brav phi v of r ket phi is equal to 4 pi into integral 0 to infinity, then put the value of v of r, that is minus v0 e raised to minus r by beta divided by r by beta into e raised to minus 2 alpha r by beta into r square dr, that is equal to minus 4 pi v0 beta into integral 0 to infinity r into e raised to minus r by beta minus 2 alpha r divided by beta dr, which is equal to minus 4 pi v0 beta integral 0 to infinity r into e raised to minus r by beta of 2 alpha plus 1 into dr, and this integral is also in the standard integral form, and here x is equal to r, a is equal to 2 alpha plus 2 alpha plus 1 by beta, and n is equal to 1. So brav phi v of r ket phi is equal to minus 4 pi v0 beta into 1 factorial divided by 2 alpha plus 1 divided by beta the whole raised to 1 plus 1, which is equal to minus 4 pi V0 beta into 1 divided by 2 alpha plus 1 the whole square divided by beta square, which is equal to minus 4 pi V0 beta cube divided by 2 alpha plus 1 the whole square. This is equation number D. Then put the values of A, B, C and D in equation 5. Then equation 5 implies that minus h cot square by 2 mu pi beta by alpha minus h cot square by 2 mu into minus 2 pi beta by alpha plus minus of 4 pi v0 beta cube divided by 2 alpha plus 1 the whole square, whole divided by pi beta cube divided by alpha cube. It is equal to alpha cube into minus h cot square by 2 mu into pi beta by alpha plus h cot square by mu pi beta by alpha minus 4 pi v0 beta cube divided by 2 alpha plus 1 the whole square, whole divided by pi beta cube, and it becomes minus h cot square by 2 mu pi alpha square beta plus h cot square by mu pi alpha square beta minus 4 pi v0 alpha cube beta cube divided by 2 alpha plus 1 the whole square and whole divided by pi beta cube, which is equal to half h cot square by mu pi alpha square beta whole divided by pi beta cube minus 4 pi v0 alpha cube beta cube divided by 2 alpha plus 1 square into pi beta cube. That is E is equal to h cot square alpha square by 2 mu beta square minus 4 v0 alpha cube divided by 2 alpha plus 1 the whole square. This is equation number 6. Then next aim to minimize the energy, that is the ground state energy is the minimum value of the expectation value of H, that is dou E by dou alpha is equal to 0. Then differentiate with respect to alpha and equating with the 0, which gives h cot square alpha by mu beta square minus, then here we apply quotient rule, then we get 2 alpha plus 1 the whole square into 4 v0 3 alpha square minus 4 v0 alpha cube into 2 alpha plus 1 into 2 whole divided by 2 alpha plus 1 the whole raised to 4. It is equal to minus v0 alpha square into 24 alpha plus 12 minus 16 alpha divided by 2 alpha plus 1 the whole cube. plus h cut square alpha by mu beta square, which is equal to h cut square alpha divided by mu beta square minus v0 alpha square into 8 alpha plus 12 divided by 2 alpha plus 1 the whole cube. That is 0 is equal to h cut square alpha by mu beta square minus 4v0 alpha square into 2 alpha plus 3 divided by 2 alpha plus 1 the whole cube. Then rearranging the equation, that is h cut square alpha divided by mu beta square is equal to 4 alpha square v0 to alpha plus 3 divided by 2 alpha plus 1 the whole cube, which implies that collecting all the constants in one side, then 2 mu v0 beta square by h cut square is equal to 2 alpha plus 1 the whole cube divided by 2 alpha into 2 alpha plus 3 is in the terms of alpha, and it is written as gamma square. The value of alpha, when we put in the expectation value of h, we get the minimizing energy. From equation 6, the expectation value of h is equal to h cut square by 2 mu into alpha square by beta square minus 4v0 alpha cube divided by 2 alpha plus 1 the whole square. H cut, that is equal to h cut square by 2 mu beta square into alpha square minus 2 mu beta square divided by h cut square into 4v0 alpha cube divided by 2 alpha plus 1 the whole square. Then taking h cut square alpha square divided by 2 mu beta square outside the bracket, then 1 minus 2 mu beta square v0 by h cut square into 4 alpha divided by 2 alpha plus 1 the whole square, and apply here the value of alpha. Then we get h cut square alpha square divided by 2 mu beta square into 1 minus, in terms of alpha, 2 alpha plus 1 the whole cube divided by 2 alpha into 2 alpha plus 3 into 4 alpha divided by 2 alpha plus 1 the whole square, which is equal to h cut square alpha square by 2 mu beta square into 1 minus 2 into 2 alpha plus 1 divided by 2 alpha plus 3. Then h is equal to h cut square alpha square by 2 mu beta square into 2 alpha plus 3 minus 4 alpha minus 2 divided by 2 alpha plus 3. That is equal to h cut square alpha square divided by 2 mu beta square into minus 2 alpha plus 1 divided by 2 alpha plus 3. We take negative sign outside the bracket, then we get minus h cut square alpha square by 2 mu beta square into 2 alpha minus 1 divided by 2 alpha plus 3. This is the minimum energy of the system, that is the E minimum. Then the experimental binding energy of E minimum is equal to 2.226 mega electron volt, and this experimental value E minimum 2.226 mega electron volt is substituted in the minimum energy expression to obtain the relation between beta and V0, and the relation between V0 and beta are called the range depth relation. The relation checked for B is equal to 1.4 into 10 raised to minus 13 centimeter, which corresponds to a meson of mass 270 ME. Then the agreement is satisfactory. And a meson is the particle which bind the proton and neutron in the nucleus, and this is called the meson theory.